So in the last lesson, we learned about counting principles. Most of those questions we dealt with last lesson were called permutations. Okay, a permutation is an arrangement of objects in a definite order. Okay, order is the important word here. For example, if you think about that one where we had a race, if two people finish first and second, and then you switch who finishes first and second, that's a different order. So it's a different permutation. Okay, if you look at this example, if we take A and B and we put A, B, and BA, those are different. They're different, so this is what's called a permutation. Okay, and a little shortcut for doing permutations is something called factorial notation. Okay, do you remember the number of times we did stuff like 5 times 4 times 3 times 2 times 1? Okay, there is a special notation for that, and it's called factorial. Okay, instead of writing 5 times 4 times 3 times 2 times 1, we can write 5 exclamation mark. Now that doesn't mean you yell it and say 5. What that means is 5 times 4 times 3 times 2 times 1. Okay, looking at this example, n factorial, that means n times 1 less times 1 less times 1 less until you get all the way to 1. Okay, and we'll use this over and over again. This is actually a spot on your calculator. If you go to Math Probability 4, you should be able to find this. Okay, maybe I'll quickly look it up for you. Okay. So if you get your calculator out, look for the factorial notation, this is how you have to find it. All right, let's clear the screen. Okay, and then you're going to see the math button. Okay, and you get this display. What you want to do is scroll to the right until you get to PRB, which is probability, and there you see it. It's number 4. Now, the problem is you need to put the number in first. So let's clear that, and let's try 5 factorial. So go 5, press Math, scroll over to probability, then press 4, and you get 5 exclamation. 120, which is 5 times 4 times 3 times 2 times 1. Okay, so determine the number of arrangements that 6 children can form when lining up to drink. So picture these 6 children. So who could go in the first spot? There's 6, and then there's 5, and then there's 4, and then there's 3, and then there's 2, and then there's 1. You don't need to do this. This is just 6 factorial. Okay, and you use your calculator, you'll get 720. Okay, let's try the next couple. Let's go 10 factorial. So 10 factorial. Okay, 3,628,800, I believe it was. Yep. Okay, and then there's this one. We'll go 12 factorial. Divided by, what is it? 9 factorial, 3 factorial. Okay, so we'll go 9. So there's divided by 9 factorial, and now we want to also divide by 3 factorial. So 220. Okay. Now here's simplify, and it has a variable in there, so this is not a calculator question. What we want to do is write this in a simpler form. Well, if we have 9 plus 3 and then 9 plus 2, that's 1 less. This is actually 9 plus 3 factorial, right? Because what's 9 plus 2 factorial? That's 9 plus 2 times 9 plus 1 plus 9, and we just keep going smaller here. So instead of doing that, this is the same as just going 9 plus 3 factorial. We don't need to write both of them. Okay? And then there's this one. How would I simplify this? Well, I'll give you a little clue. Simplify the bigger of these two, the larger one. So what's bigger, n plus 1 or n minus 1? Well, hopefully it makes sense that n plus 1 is bigger. So let's reduce that. So we'll go n plus 1. What's 1 less than n plus 1? N. What's 1 less than n minus 1? And I'm going to stop there because I notice that's what the bottom says. And n minus 1 cancels out. So simplified, this is just n times n plus 1, which is n squared plus n. Okay, my little clue there, look at which one's bigger. Okay, so solve. This is an example of where you have to use that. Okay, which of these is bigger? I think n is bigger than n minus 2. Okay, so I'm just going to write this. You don't have to. N is bigger than n minus 2. So I'm going to reduce the top. N times 1 less times 1 less. And I'm stopping because I see n minus 2 in the denominator. Okay. So the factorial notation cancels out, and I'm left with just n times n minus 1. Okay. Now what? Well, we could probably do a little guessing and checking what value of n might work here. Okay, what times 1? I need two numbers that are 1 apart. You know, like what's 9 times 8? Well, that would be 72. What about 8 times 7? That'd be 56. Let's go bigger. What about 10 times 9? Yeah, that's 90. So I think that means that n is 10. Okay? Now, there's another way to solve that, and that's using algebra. Now, I'm not sure. I'm going to have to look into this to see if this is something you're going to have to do. But what I brought is the 90 over to the left side, and then I'm going to do something called factoring. If you remember this from grade 10. All right, factoring this, what multiplies to negative 90 and adds to negative 1? Negative 10 and positive 9. All right, and so then what has to happen is either n minus 10 equals 0 or n plus 9 equals 0. So that means n is 10 and n is negative 9. And it can't be negative 9. You can't have a negative number for factorial. So there's our answer. N is 10. Okay, and that's it for this lesson. All right, if you could do page 243, numbers 1, 2, and 4 to 16.